My name is Hend, and I'm an assistant professor at Fresno State. I joined Fresno State last August, so just arrived here. I used to live in Tunisia, so I was teaching enology. Now I'm teaching wine chemistry and production. So I have an industry background, so I care a lot about industry. So I guess that's why I'm here. So thanks, guys, for inviting me to talk here. Just wanted to tell you, so this is, I gathered some of the results of the research that Noma Cork had done during last years with different institutes on how they assess the impact of bottling on wine quality. Okay, so so when we talk about managing bottling effect on wine quality. So we're going to care more about that we call the total package oxygen. So I'm not going to focus on this. This work has already been published and already been discussed a lot. So what our interest is today to discuss more on how the bottling will affect the quality. So when we talk about this TPO, we include these two notions, so the headspace and the dissolved oxygen. So basically, what the research was done is they tried to change different kind of management of these characters, the headspace and dissolved oxygen, and see how these are going to affect the quality. So in this TPO, as I said, so there is HSO and DO. So this DO and HSO are dependent on how you're going to manage your bottling. So basically, the performance of the inerting of a wine prior bottling, and also how you're going to store it and transfer it during bottling as well, and also how the oxygen is going to pick in. These are the things that are going to influence these characters that are going to be then affecting wine quality. So there were different experiments that were done, so different experiments based on different factors that could affect the quality. The first one was initial SO2, the one that is kept in the wine prior bottling, so the free SO2 in the wine prior bottling, and how that is going to be affecting as well how TPO is going to be influencing your wine quality. So whether you start with higher SO2 wines or lower SO2 wines, the impact of TPO is not going to be the same. So we're going to see this in one of the experiments. Type of wine, so whether we treat a white or red wine, this is not going to be reacting the same way to bottling. So one of the researchers also done to compare these two type of wines in accordance with how they will be assimilating oxygen during bottling. Cold stabilization is known to occur at cold temperatures, so temperature is known to affect also stabilization of oxygen. And since it's affecting solubilization, it's also being critical for the wine quality, so also it's going to be part of these experiments. Temperature is also a critical factor that's going to impact the reaction of oxygen in the wine, and also how it's going to be dissolved. So with the first experiment, so two different wines were tested. So one with high SO2 amounts, and the other one was Chardonnay with low SO2. This was done to see if there is difference when we treat a non-organic and organic wine. So the first wine was a Riesling from Germany, so known to have higher SO2 amounts, of free SO2 amounts of 50 ppm minimum. The low Chardonnay SO2 amount was under 10 ppm, and the idea is to see if organic or non-organic wines are going to behave same way according to bottling. So when focusing on bottling, as I said previously, we're going to focus on two characters, what are the headspace and also the dissolved oxygen. So the idea was to manage these two factors, so HSO and DO, and see how they separately influence the quality. So the wine that was analyzed in this case is a high SO2 white wine, which is, as I said previously, a Riesling from Germany. So I've taken, again, the slide that Malcolm showed previously just to start with how they selected the concentration of DO and HSO in the experiments, but based on the results of conducted on different filling heads and different experiments where they assessed the concentration of HS and DO in the wines. And they found out that the concentration usually ranges between 0.2 and 6 ppm. So based on this, the experiments were built. So 3 treatments were done. So first we tried to work more on managing SO2 and fixing DO. So DO was kept stable at 1.1 milligram per liter, so the same wine was taken. The same wine with same DO, but then different headspace oxygen concentration were managed according to the concentrations I previously mentioned. So the lower amount was about 0.4 and the high amount was about 5.7 milligrams per liter. So based on this, we're going to see if the concentration of oxygen in the headspace is affecting wine quality and how it affects that. So in this graph, I report the effect of HSO management, so a different concentration of headspace oxygen, on how free SO2 is going to decrease during after bottling. So the first phase, what you see here, is the one that follows the bottling, immediately follows the bottling. In this area, it's more due to the headspace oxygen. So you see that there is a fast decrease in the third, fourth, first months. So this faster decrease of SO2, of free SO2, is more intense when HSO is higher. So in the blue color here line, you have the higher concentration of headspace oxygen. So you see the higher the concentration of headspace oxygen, the faster is going to be the decrease of your free SO2. So what else to say is that this is the part where your HSO is going to be more affecting your wine quality. After that, and the next month, it's going to be more your closure, which is going to be influencing the decrease of SO2. So well, we're not going to detail this, but you see that this rate is slower, so the decrease is slower, and this is basically due to the closure and the ingress of oxygen through the closure. So how this then HSO concentration affects the sensory of the wine. So we can see in this graph there is 2 concentrations, so the lower one and the higher one that we have seen previously in the treatments. And we see that there is an overall good impression for the wines that has lower headspace oxygen compared to the ones that have higher HSO in the bottle. So if you see the reduction character, we can think slightly, there is a slightly more reductive character in the wines that have a lower HSO compared to the ones, but this is, we can think that this may be related to HSO, but we're going to see in the next slide it's not related to that. And the character that related to the developed character, the evolution character, we see that's more dependent on the HSO here, which is in higher concentrations. So so does high SSO mean no reduction? So as I said in the previous slide, that if you have high HSO, you expect not to have a higher reduction character. But as you can see in these results, where you can see the 2 different kind of kind of stoppers. So this is a normal class, and this is a screw cap. In these 2 cases, we can still have the same reductive character in both cases, whether we have low HSO or high HSO. So it doesn't mean, so if we increase HSO, it doesn't mean that we're going to reduce the reduced character in the wines, which is here represented by the H2S. Yeah, so, well, reduction is usually known to be developing after 3 to 6 months after bottling. So this cannot be due to HSO, since HSO is acting more in the first months. So this is a second experiment where we, instead of varying headspace oxygen, there was only variation of DO. So headspace was kept constant at 2%. And it's only the DO which was managed, so with purging nitrogen at the beginning to get lower DO values, and no purging for getting medium level. So medium level is about 2.5 ppm, good one, which is a low one with 1 ppm. And the last one was with purging oxygen to get a higher amount of DO. So this is based on industry standards, okay? So different, remember, so different levels of DO and same HSO. Different stoppers were also tried in this case, high, low, and high ingress oxygen and low ingress oxygen, and screw caps. So this is a result of the consumption of oxygen after bottling in this experiment. And as you can see, so there is the oxygen, the DO tend to decrease, so it becomes 0 at the end for all type of closures. And the consumption, as you compare different type of DO, so this is the dark blue ones is the low DO in this case, and the light blue is the higher DO. So you see there is a higher, the speed of the decrease in here is higher than this one. But of course, this is going to be becoming 0 faster because the concentration, initial concentration is lower. But you can see that with higher DOs, the decrease is much faster. So the consumption is immediate when the initial DO is higher. In this case, so same experiment, we wanted to check the effect on free SO2 loss. So this is in terms of loss, so it's a variation of SO2. And you see, this is the different type of different treatments, so DO levels, so and these are the different stoppers. And you can see that from a 1 ppm DO to from 1 ppm DO to 2 ppm DO, so this is 1 ppm DO, this is 2 ppm DO. This is the same case, so from 1 to 2, from 1 to 2. Oh no, let's see, yeah? Maybe, yeah, from 1 to 2. So you have a small but significant effect on free SO2, which is about 2 units. So there is a small effect in here, but the effect is higher when the DO is higher. So when you increase the DO to 5 ppm, the difference of the loss of free SO2 is going to be more important. So when you start with high DO concentrations, the decrease of your free SO2 is going to be more important and more significant. And this was seen in all type of closures. The effect on sensory, so this is only the oxidation character. I think my colleague talked about it, like same experiment on Riesling previously, so I'm gonna take it back. So this experiment also shows the impact of the DO on the oxidative character of the wines. And you can see that there is no difference between good and average. So this is a good, so low DO, this is good. And this is average DO, so there is no difference. So AA, BB, AA, BB. So, but there is higher when the DO is higher, like this case in here. You see there is a difference which is significant between with the others. So with higher DO, there is noticeably a significant oxidized character compared to medium and low DOs. This is still the effect on sensory, and this represents the different type of treatments and the different characters and the different attributes, sensory attributes that you can get in these wines. So in this circle, so in this area you have the wines that has lower DOs, and in this one you have the area of wines which has the higher DOs. And you see that these wines have more fresh, fruity characters with more CO2 in them. In this area with higher DOs, you have more oxidative, more evolution, more character ripeness character than in the others. So these ones with lower DO, I can join my colleague Jean-Baptiste when he talked about CO2 and how the oxygen and CO2 exchange occurs in bottles. That when you get lower oxygen ingress in the wine, you can have more available CO2 in your wines. And that explains why you have here in these lower DO wines more CO2. So this is the experiment that was done on wines which has low SO2 at bottling. This was done to see if this TPO affects the same way organic or non-organic wines, wines with high SO2 or others. And so Chardonnay was tested with 2 TPO levels, so 0.5 and 3 milligrams per liter. And as you can see, it's the same thing. So more oxidized character in the case where you have higher TPO. So more oxidized, oh, it's in French, but I can't translate that. This is oxidized, this is reduce it. Aromatic intensity, citrus, exotic fruits, yellow fruits, like apples, like what? Peach, yeah, floral, honey, caramel type of fruit. So this red color it presents the high TPOs, and this is more like related to more kind of evoluted oxidized character. And that's in the other side, you have more fruity, more fresh type of aromas. So, so this is oxidation occurs within 4 months when exposed to an extra 2.5 milligrams. So this is the difference between the 2 treatments. So there is 2.5 milligrams per liter for 2 TPOs. So when you expose your wine to more than 2.5 milligrams per liter, you tend to oxidize it. And this happens already within 4 months because 4 months is the period where your TPO is going to be more active. So if you want, so very low TPO are important. So if you want to work with organic wines, you have to really manage seriously your bottling. If you don't manage that, you're going to definitely reduce shelf lives of your wines. So very careful on how you bottle your organic wines if you want to do that. So the other aspect that we wanted to see is the type of wine, so whether there is a difference between whites and reds. Since we know that reds are going to have different reactions to oxygen and SO2 as well, we know that red has in their composition phenolic compounds, and if you have oxygen in wine, phenolics are going to take that oxygen through their condensation and polymerization reactions. So it may not react the same way. So we wanted to do this as to see if TPO bottling has an effect on these red wines too, and how intense is this effect. I talk like we, I did, but I didn't. It's not my job. But yeah, it's kind of habit. Grenache, but I feel concerned. I'm going to be concerned soon. Exactly. Yeah. So, so Grenache was the one that was tasted, and so the 2 concentrations that was tried on DO. So we changed only DOs, and we tried 1 milligram per liter and 3 milligram per liter. So low and average one. There is no data about high DOs in here. But you can see already that when you compare the free SO2 decrease in the 2 cases, this is with low and this is with medium DO, you see that still the same behavior as in white. So there's always a fast decrease, and in the first months, so first days already, it's very fast. We can think that this is not only due to the same type of reactions that occur in whites, but in order to understand that, we conducted more research on color intensity, oxidation character measured spectrophotometrically. And the next slides, so this is the first one, which represents the red color intensity expressed as sorbents at 520 nanometers. And we're gonna, this is different type of closure, so we're not gonna look at this area because this happens more due to closures. But we considered more by bit this area where the TPO is gonna act most. And you see that the color intensity increases immediately after bottling. So right after bottling, there is a high increase, a very quick increase. So if you change your TPO of 2 ppms, you're going to be responsible of about 0.4 units of your color measured in terms of absorbance. So it's very important. What's going to happen in the wine is that you have appearance of new red pigments due to reactions that involve oxygen. Oxygen is known to be oxidizing ethanol, so it produces acetaldehyde, and acetaldehyde can be responsible of condensation, polymerization reactions, intensification of color, but also synthesis of a new type of anthocyanins that are known to be more intense in color, but also has a more orange type of color that we can see in this slide be more clear. Like when we measure the 420, which represents more the oxidized color, the brown color, we can think this is due to oxidation, but it also due to synthesis of other type of anthocyanins that change structure into pyranthocyanins that are more, this is more science, but I know I'm very passionate about that. But pyranthocyanins is another type of anthocyanins that has another cycle, and this cycle forms due to oxidation. So mainly acetaldehyde is going to be responsible of this, but other compounds as well, like pyruvic acid and other stuff, can be involved in these reactions. So we can think this is due to oxidation, but not only oxidation, which is bad, but also can be more stable type of oxidation. But still, it's very important, as you see in these results, that TPO is affecting a lot red color as well, in terms of intensity, but also on type of color. So it's going to tend more at brown, orange type. So the other point that they wanted to check, like the cold stabilization, how you manage cold stabilization. Two types of filling, so whether the tank is full, completely full, or half full. We want to see if that affects as well how TPO is going to change the wine quality. In this case as well, three type of closers were tested. And in this graph, we see how the free SO2 evolves. So this first one here, this is more for full tanks, so full tanks that were cold stabilized, so completely filled with wine. So there is always a decrease of free SO2, but it is more intense when you have half full cold stabilized tank. So whether you have oxygen available in your tanks or not is going to affect as well how your oxygen will be reacting in your wine. So basically through a measurement of free SO2. So this is known to be, because it's cold stabilized, so it's temperature related. So when we talk about cold stabilization, we care a lot about temperature, since we know that cold temperature increases oxygen solubilization. So we can see in this table that when you increase temperature, you're going to have the air saturate. The more we're going to be soluble. So your oxygen is going to be more soluble. The lower the temperature, the more the lower the temperature, the more the oxygen is going to be soluble. The higher the temperature, the less is going to be soluble. So, but after that, you're going to have more the reactions that are going to involve oxygen is going to occur more at higher temperatures. So this can lead us to think, so when you bottle your wine, you'd better bottle it at higher temperatures and then store it at lower temperatures. Okay, because it's when you bottle your wine that you're going to dissolve more oxygen. So the better dissolve it, keep temperatures not lower enough to make the oxygen being dissolved quickly. But after that, if you want your reactions not to happen, you have to keep it stored at lower temperatures. So this was another experiment that related to temperature. So this was a measurement of temperature in tanks. And this represented where you're going to measure your oxygen. This is a distance to the surface of the wine, so whether you go deeper or not is going to affect as well the concentration of oxygen. So you see in this graph that when you're closer to the surface, you're going to have more oxygen available. So when you measure your oxygen, the highest concentrations of oxygen is going to be the ones that are on the surface or close to the surface. And this is also compare different temperatures. So you see in here that when you have lower temperatures, you have more oxygen. So this also confirms what I said previously. So you dissolve more oxygen at lower temperatures. So where to measure also affects also how much oxygen you're gonna get. So in conclusion, so TPO is important. So if you want to manage your shelf life of your wine, if you want to keep your wine a long time stable, you need to care about bottling. So I've shown previously how it affects the stability of the wine, but also how it affects the sensory of it. Whether it's a white or red, whether it's a high SO2 or low SO2, it's always going to be dependent on the bottling. So if you want, the first 3 months are going to be the ones that are going to be more affected by this bottling process. After that, you're going to see more of the closure affecting the wine characters. On the other hand, so TPO, as I said previously, is not going to prevent reduction. So reduction is not related to that. So remember the graph we showed about the screw cap and the normal core cap that not affected by HSO. So that leads to think that if you increase TPO, you're not going to prevent reduction. So phenolic compounds and sensory attributes are affected by bottling conditions. So careful. That's all. Thank you. Lee.